All right, today we're doing theorems involving parallel lines. The theorems involving parallel lines are a little bit different than the ones we've done in the past with transversals. These have to do with different shapes like triangles and parallelograms. The first theorem says that if two lines are parallel, then all the points on one line are equidistant to an opposite point on another line. That's not to say that AD is congruent to BC, just that AC, when drawn at a perpendicular angle, is equidistant just as BD would be equidistant to each other, as long as these two sections right here are perpendicular to each other. The next theorem says that if three parallel lines are cut off in congruent segments on one transversal, then they are cut off in congruent segments on every transversal, meaning if we have three parallel lines and one cut off transversal, each of those segments, as long as it's given that AB and BC are congruent, then any other transversal, for instance XZ, would create congruent segments of their own, making XY and YZ congruent. Now we'll see this in later theorems as to why this is true, but this is the original theorem, and to prove that, we create these auxiliary lines of XR and YS to create angles 3 and 1 to be corresponding. 1 and 5 then become congruent as a isosceles triangle, and then from there we could prove that XY would be congruent to YZ because the top triangle XRY and triangle YRZ or YSZ would be congruent. And then CPCTC would say that XY and YZ would be congruent. Using that theorem, we can then say that if you have a parallel line and it passes through a triangle, if it contains the midpoint on one side of the triangle, it also creates the midpoint on the other. So to refer back to this theorem right here, you see we have three parallel lines, and notice on the next theorem there are only two parallel lines, but the auxiliary line of the third passes through the top point of the triangle, creating two congruent segments and the transversal AB. Therefore, using that previous theorem, we could then conclude that AN is congruent to NC, and therefore N would be the midpoint of AC. After that, if we know that a segment joins the midpoints on both sides of a triangle, we could conclude two things. One, that it's parallel to the third side, and it is half as long as the third side as well. So MN is half the length of BC. Here's a couple of examples to have you practice this. Hit pause and practice these now. If RS is 12 and using the given information, I hope you could conclude that ST was also 12. If AB is 8, then BC is also 8. If AC is 20, AB would be half of that as 10. And if AC is 10x, then BC is 5x. Take a second, hit pause, and on the first side of your practice sheet, answer questions 1 through 7 now. Okay, turn the paper over, and in the next example, you'll see some information given where we have information about what type of points P, Q, and R are, and then from there we are able to make some conclusions about some other sides and other lengths in the figure. P, Q, and R are the midpoints of the sides of triangle DEF. From there, what kind of figure could you conclude DPR would be? Hopefully you could conclude that DPQR is a parallelogram because if R and Q are midpoints of the triangle, then we know that RQ is opposite DE and therefore parallel to DP. Same thing with P and Q, both midpoints of triangle DEF. Therefore, we could conclude that PQ is also parallel to DR, making opposite sides of a quadrilateral parallel and thus a parallelogram. Going to the next question, what is the perimeter of DPQR? The perimeter of DPQR can be found by using the other theorem, making DF double DR, making DR4, making DP6, making PQ the opposite of DR also 4, and then making RQ the opposite of DP6. So your perimeter would be 6 plus 4 plus 6 plus 4, or 20. Take a second right now and answer questions 8, 9, and 10 on your worksheet. And finally, one proof that we're going to do. LOPR is a parallelogram with triangle LRM and POQ congruent to each other. And our goal is to prove that MOQR is a parallelogram. Hit pause, take a second, and try to fill in the blanks for the reasons of the proof. Okay, hopefully you obviously had given for step number 1. For step number 2, RM and OQ, LM and PQ are congruent by CP/CTC. After that, LO, PR, and LO and PR are both equal and congruent. Opposite sides of a parallelogram are congruent. From there, you added LO with LM, and LO equals LM and MO, with PR equaling PQ plus QR as the segment addition postulate. MO and QR are congruent using substitution. And finally, MOQR is a parallelogram because opposite sides of a quadrilateral are congruent. At this time, finish the rest of the worksheet for homework, and we'll see you in class.